Welcome to today's live. And today we are working on the exercise 8B, and this is the episode 6 on this exercise. The main topic of this exercise is stationary points, the further differentiation. This is the course book of the Pure Maths 1. So today we already have done 5 episodes on it, and today we are going to do the 6th one. In this episode, we are on the last questions of this exercise, which is the question number 12, which is question number 12. He says that the y is equals to x square plus a by x plus b, and has a stationary point. It has a stationary point at 3, 5. Okay. Find that this is the A part. Their question is find the value of the A and the value of the B. Here we have equation given, and question number 12, it says y is equals to x square plus a divided by the x plus b, and we have stationary point at 3, 5. We want to find out the value of the a and the value of the b. Okay, so because this point is on that on that curve. So in the equation of that curve, in the place of x and y, I can put 3 and 5. So what we will do, in the place of x, I will put, in the place of y, I will put 5, and in the place of x, I will put 3. So it will be 3 square a by 3 plus b. So it will be 5 equals to 9 plus a by 3 plus b. Okay. So you see, I put in the place of x, I put 3. In the place of y, I put 5. Then I multiply. So this will be 5 minus 9, that is 4 equals to a by 3 plus b. You see this? Now I can multiply with the 3. All the terms multiply with 3. So you will have 12 equals to a plus 3b. So I can write a plus 3b is equals to 12. So this is my first equation. Okay. So I found the first equation in terms of a and b, and that I found is by putting the x equals to 3 and the y equals to 5 in the original equation. Okay, now I'm going to derivate it because the stationary point is at 3, 5. So we can derivate it. So y is equals to it is x square plus a into the x raised by minus 1 plus b. So I will derivate this. So we will have y equals to 2x plus a into minus 1 into the x raised by minus 2 plus 0. So y will be equals to, and this is dy by dx, sorry. So dy by the dx will be equals to 2x minus a divided by the x square. So this is the expression for the dy by the dx. Now you know at the stationary point, the dy by the dx will be equals to 0. Okay, at the stationary point, the dy by the dx at the stationary point, the dy by the dx will be equal to 0. So that means 2x minus a by the x square. What is the value of the x? That is 3. And the dy by dx is 0. So 2 into 3 minus a divided by 3 square, 0. This is 6 minus a by 9 equal to 0. So minus a by 9 is equal to minus minus 6. So a is equals to 6 into 9, and the a will be equals to 54. I got the value of the a. Okay. So at the stationary point, you know the dy by the dx will be 0, and the stationary point is at x equals to 3. And so what we did is in the dy by dx, I put that equals to 0, and in the place of x, I substituted 3. So from there, I got the value of a. The value of the a is 54. Now I can find the value of the b. You know the a plus 3b is equals to 12. So if a is 54, then what will be the b? 12 minus 54. So 3b will be equals to, this is 2, 3 minus 32 by 3. Okay. Let me check first of all if it's correct. He said 22. I made some mistake. The value of the a is 54. That is correct. And the value of the b will be minus 22. Something went wrong. A plus 3b equals 12. A is 54. So 54 minus 32. Why come it's not? I put 3 here. That's 9 plus 8. Where's 9? It's minus. It's minus 12. Yes, this is the mistake. So this is minus 12. This is minus 12. This is minus 12 plus 52. So 2 2s are, so 4. What happened here? This is 9. What about 9b? So I multiplied every term with, you went there, subtract here, minus 4, a by 3 plus b. So you multiply with the 3 minus 12 equals to a plus 3b. So a plus 3b equals to minus 12. Okay. So from here, we got the value of the a, that's 54. So when I put the 54 here, minus 12, okay. So when this goes there, this becomes minus 54, and this becomes 6 and 6, and this becomes 66 divided by 3. So b is equals to minus 22. Now it's correct. Yes. Yes, sir. You see, we got the value of the b, that's minus 22. This is correct. So that's the a part where we have to find out the value of the a and the value of the b. Okay. I made a mistake of the sign. So, okay. Then their question is, that was the a part. Then their question is, we have the b part. Determine the nature of the stationary point at 3, 5. Okay. So we have to determine the nature of the stationary point at 3, 5. So now we are at the b part of this question. In the b part, we have to find out the nature. Okay. So for that, I need the second derivative, dy by the dx is equals to, we have 2x minus, the value of the a is 54 divided by x. Yeah. So this is my first derivative. So dy by the dx is equals to the 2x minus 54 and x raised to minus 2. So this is my first derivative. Now I will differentiate it again. I will find the second derivative. So that will be that will be 2 minus 54 into minus 2 into the x raised to power minus 3. So my second derivative will be 2 plus 8 10 divided by x cubed. Okay. Now the nature, I want to check the nature of this point. So at x equals to 3. So my d square y by the dx square 2 plus 108 divided by 3 cube, that is 2 plus 108 divided by 27, so that is 4, that is 6, which is positive. So the point at the 3 comma 5, because the second derivative is positive, minimum point. It's a minimum point. Okay, so this will be a minimum point. Okay, so this is the B part of this question. Then we have other point, the C point now, and the C part I mean. He says find the range of values of the x for which the x square plus a by x plus b is decreasing. Okay. This is the C part. Their question is that we have to find the range of the values of the x for which the y equals to x square plus this becomes 54 by the x, and the b value is minus 22. Minus 22 is decreasing. We have to find out the range of values of the x. Okay. You know that the function will be decreasing when its dy by the dx will be negative. If the dy by the dx will be negative, the function will be decreasing. Okay. Now we know the dy by dx. That is here. Dy by the dx. We already know that dy by the dx is equal to 2x minus 254, the value of the by the x square. When this is negative, then that function is decreasing. Okay. Now the turning point is 3 comma 5. So this will be infinite at if in the place of x I will put 0, this thing will become infinite. Because in the denominator the x is what is the x? If I put x equals to 0, this whole thing will become infinite. So if I draw a graph, at the 0, this graph will be infinite. Okay. So with the help of the calculator, today I have, okay. For example, when I put 1 in it, so what happens? 2 multiply 1 minus 54 divided by 1 square equals to, at 1 the value is minus 52. At 1 the value is here somewhere. Okay. So okay. Then what is the value? 2 multiply 2 minus 54 divided by the 2 square. 2 square. Can we have square? Yeah. So it will be minus 9.5. So this is 1 comma. Okay. At 2 it is minus 9.5. It will be here somewhere. Okay. Suppose it is here. At 3, if I put 3, then 2 multiply 3 minus 54 divided by 3 square. So you will get 0. At 3, this is 0. And at 4, what will be the value? At 4, it will be 2 into the 4 minus 54 divided by the 4 and its square equals to, that will be positive 4 point something. Okay, and what will be the value at the 5? Okay, 2 into the 5 minus 54 divided by 5 and its square, so that will be 7.8. So it will be here somewhere. So the graph is coming, this is the infinite. It's going like this. Okay, so after this point the graph has gone into the positive portion. Okay, now I will put some negative values, we will see what happens. Suppose -1, -2, -3, -4. Okay, so let me put the 2 bracket -1 bracket close minus 54 divided by bracket -1 bracket close square, sorry, bracket close and square, and equals to, the value is minus 56 here somewhere. Okay, okay, then we will have -2, 2 multiply, sorry, 2 multiply bracket start -2 bracket close minus 54 divided by bracket minus 2 bracket close square equals to, so at 2 it's minus 17 somewhere here. Okay, and at -3, 2 multiply bracket -3 bracket close minus 54 divided by -3 bracket close square equals to, at -3 it's -12 somewhere here. Okay, then at -4, 2 multiply -4 bracket close, and then we have -54 divided by bracket -4 bracket close square equals to, it's 11, so it will be here somewhere, suppose. Okay, so then I can check on -5, okay, because it's going to cross here. Okay, let's see. 2 multiply bracket -5 bracket close, then we have -54 divided by bracket -5 bracket close square equals to, it's -12 point something, so it's going near, it's going like this. Okay, so let me try on when it will be 0. The other number will be, let me try, instead of finding this I can make it this equal to 0. So let's see, 2x minus 54 by the x square is equal to 0. So you will have 2x cube minus 54 equals to 0. So 2x cube is equals to positive 54. So the x cube will be equals to 54 divided by the 2. So the x cube will be equals to, it will be 2. 2 to the 4 and 1 7. So when you take that is 3. Okay, so we already know that point. So the graph is, I think, positive, and the graph is negative. And can you see when the graph is, this is the graph for the dy by dx. So I tried till -6. So when is your dy by dx graph is negative? Here you can see this portion. Your dy by dx graph is in the negative portion. So my one answer is greater than 0 and less than 3. This is one answer. Okay, but here the graph is infinite. Okay, this is going like this. But here also the graph is in the negative portion. Okay, so I can say the x is, I can say x is less than 0. Not equals to 0, okay? So these are the answers. You see, we have to draw a graph, and then from the graph, I decide, okay? I draw the graph of the dy by the dx, and from there, I decide that when the dy by dx value is negative, for which values of the x, the dy by dx is negative. Wherever the dy by the dx is negative, this function is decreasing. If the dy by dx value will be positive, this function will be increasing. So this last part, C part, is a bit difficult, a little bit difficult, I can say. But if you have this idea, then it's not a big deal. You just have to draw it. Okay, if you do not get confused, then it's no problem. So this is exercise 8B, episode 6. The topic is stationary points, a subtopic of further differentiation. This is the course book of the Pure Mathematics 1. My name is Ferhan Mazher, and this was the question number 12 we have done. I hope you understand this. So let's do the next one. That's the last question of this exercise, and that is question number 13. You see, these last questions are huge. So they have a lot of working in them. So question number 13. So we have to, you see, the main purpose of these videos is to solve the course book, okay? So you see that the whole solution of this course book, we will try to provide on the YouTube for all the students free of cost. So the weak students, they will be able to do this course book. They will get help. And so by doing the course book, they will be able to master this concept, okay? So question number 13 coming up on your screen. Here we have the question number 13. Here we have the curve y equals to 2x cubed and plus ax squared. Y is equals to y equals to 2x cubed plus ax squared. Then we have plus bx plus 7. And the stationary point is at 2 comma minus 13. Find the value of the a and the b. This is the a part we are going to attempt. Is the kind of the a part is again the same kind of question. You see, it says y is equal to 2x cubed plus ax squared plus bx plus 7, and then they say that the stationary point is at 2 comma minus 13, and we have to find the value of the a and the value of the b. Okay, so if you want to find out the value of the a or the value of the b, first of all, I will put this point 2 comma minus 13 into this equation, and because in the place of the x I will put 2, and in the place of the y I will put minus 13, and so minus 13 equals to 2 into 2 cube plus a into 2 square plus b into 2 plus 7. So minus 13 is equal to 8, 8 2s are 16, 4a plus 2b plus 7. So 7 plus 16. Okay, take this to the other side. This will become minus 29 and then minus 7. So that is equals to the 4a plus 2b. This will become minus 36 equals to 4a plus 2b. Divide everyone with the 2. So you have 2a plus b is equals to 2 1s are 2, 2 8s are 16. And so this is my first equation. 2a plus b is equals to 2a plus b is equals to minus 18. 29 minus 7, that's minus 36, minus 29 minus 7, minus 36 and minus 13 and minus 16, that will be minus 29. Yes, that's right. That looks good. Okay. Now, because we know that at 2 comma minus 13, we have the stationary point, so we have to derivate it first. So we will derivate this equation. So y, you know the y is equals to 2x cube plus ax square plus bx plus 7. So this is my equation. So we will derivate it dy by dx. So the dy by the dx will be equals to 2 into 3 into x square plus a into 2 into x plus b plus 0. So my dy by the dx will be equals to 6x square plus 2ax plus b. So this is how I will derivate it. So you know at the stationary point, the dy by the dx, that is equals to 0. Dy by the dx will be 0. So the stationary point is at x equals to 2. So at the stationary point at x equals to 2, dy by the dx should be 0. Okay, dy by the dx will be equals to 0. So now in the expression of the dy by the dx, what I will do, I will substitute x with the 2 and I will make that whole expression equals to 0. Okay, so I write here the d6 into 2 square plus 2a into 2 plus b equals to 0. So you can see in the place of the x I put 2 and I made the dy by dx equals 0. So you will have 4a plus b, and this will be 4 2 the 24 equals 0. So 4a plus b is equals to minus 24. So this is my second equation. So now you can see that we have two equations in A and B, and we can solve them simultaneously. Okay, so just simply subtract them with each other. So you will get rid of the B. So you can write here 2a plus b minus 4a plus b is equals to minus 18 minus minus 24. So you will have 2a plus b minus 4a minus b equals to minus 18 plus 24. So I have subtracted these two. From this, I subtracted this. So you will have minus 2a equals to, so 2 and 4, 6. So a will be equals to 6 divided by minus 2. So a will be equals to minus 3. So the value of the a is minus 3. The value of the a is minus 3, which is the right answer, sir. Okay, now I can put the value of the a into the first equation, or if you want to do it, you can put this value into the second equation there. So I can write here 2 into minus 3. I'm going to use the first one, plus b equals to minus 18. Okay, so in this I put the a. I substitute the value of the a. So you will have minus 6 plus b equals to minus 18. So b will be equals to minus 18 plus 6. So the b will be equals to minus 18, and this is minus 12. So the value of the b is minus 12. Okay, the value of the b came out to be minus 12. So this is, let me check, sir. Yeah, the b answer is minus 12. So our the a part is done. Its answers are correct. The a value is minus 3 and the b value is okay. Then he says find the coordinates of the second stationary point on the curve. Okay, so we have to find out the second stationary point. To find out the second stationary point, I can say this is the b part now. At stationary point, the value of the dy by the dx, which is equals to, there, what dy by dx is 6x square and plus 2ax. The value of the a is minus 3x plus b. The value of the b is minus 12, and that should be 0. Okay. At the stationary point, we know that the value of the dy by the dx must be 0. So I will, you see here, this becomes 6x square minus 6x minus 12 equals to 0. Okay. So then divide everybody with the 6. So you get minus 2. So this is okay. Now I can do the midterm breaking here very easily. You can do the midterm breaking. So this is x square minus 2x plus x minus 2 equals 0. So I can take x common. So x minus 2, and I can take plus 1 common. Here it will be x minus 2 equals 0. So this is x minus 2 into the x plus 1 equals to 0. So x minus 2 equals 0. So the x is equals to the 2, and x plus 1 equals to 0. So x equals to minus 1. So that x equals to 2, we already know that. This is my other, the second stationary point. Here the value of the x is minus 1. Now because I want to find out its y coordinate of the second stationary point, here the x value is minus 1. So what I will do in the original equation, I will put the value of the a, I will put the value of the b, I will put the value of the x as minus 1. Okay, I know the value of the a, I know the value. For this, I am going to find out the value of the y. This point is already known. Okay, so y will be equals to 2 into minus 1 and its cube plus a, which is minus 3 into minus 1 and its square plus b is minus 12 into x, which is minus 1 plus 7. Okay, so I'm trying to find out the y coordinate of that stationary point. I know the equation of the curve, I know the x of that point, minus 1, and I'm trying to find out the y. Okay, so it will become minus 2 plus 1 minus 3 plus 12 plus 7. So minus 5 plus 7, that minus 5 plus 12, that is 7 plus 7. So y is equal to 14. So the other stationary point, its coordinates are minus 1 and 14. So let me check the answer, sir. Minus 1 and 14. Yes, sir. The B part's answer is right. The other stationary point, its coordinates are minus 1 comma 14. So our B part is correct. So we have done the A part and we also have done the B part. Okay. Now we have the C part for this. He says determine the nature of the two stationary points on the curve. Okay. Determine the nature of the two stationary points. Okay. So if you want to find out the nature of the stationary points, so we are working on the C part. Okay. So if you want to find out the nature of those points, so we have to find out the second derivative. So y is equals to 2x cube. The value of the a is -3, so it will become minus 3x square minus 12x plus 7. So this is my equation. Okay. So sorry, I wrote the equation. We already know its derivative. Okay. And its derivative we already know is, I don't need to write this. Okay. So we can write directly dy by the dx. The dy by the dx is already we have converted, that is 6x square minus 2 into minus 3 into the x and minus 12. So my dy by the dx is equal to 6x square minus 6x minus 12. Now I can find the second derivative. The second derivative will be d square y by the dx square, and that will be equal to the 12x minus 6. Now you see we have found the second derivative. C part I am doing. We know the dy by dx already. To find out the nature of the stationary points, I need to know the second derivative. So I did. We found the second derivative. Now we will put the x coordinates of the two stationary points one by one into this second derivative, and we will see what the answer we get. Okay. So at x is equals to 2, the d square y by the dx square, its formula will become 12 into 2 minus 6. So this becomes 24 minus 6. So this is equal to the 18, which is positive. So that means 2 comma minus 13 is a minimum point. Minimum point. Let me check. See, 2 comma minus 13 is a minimum point, and that answer is right. 2 comma minus 13 is a minimum point. That is right. Okay. Now I can put x equals to -1. Okay. So at x equals to -1, d square y by the dx square will be equals to 12 into the -1 minus 6. So this is minus 12 minus 6, which is minus 18. So it's negative. So that means the -1 comma 14, that's a maximum point. Okay. So this is my C part. Okay. Let me check this answer as well. Okay. So 2 comma minus 13 minimum point, -1 comma 14, that's the maximum point. So this is the C part of the question number 13. Now we will go to the next part, and the next part coming up on your screen is, he says find the coordinates of the point on the curve where the gradient is minimum. Okay, I know the, okay, and state the value of the minimum gradient. Okay, so where is the gradient minimum? You know, this is the formula. This is dy by dx represents, this is the d part. Now, the gradient is represented by this, okay? The dy by the dx, this represents the gradient. And this is basically dy by dx is equals to 6x square minus 6x and minus 12. So this is basically representing the gradient of that curve. So the gradient of that curve is this. Okay? The gradient of that curve is represented by this dy by the dx, and that is 6x square minus 6x minus 12. That represents the gradient dy by dx. Their question is, where is the gradient minimum? So for this expression, you know, this is a happy phase. So its minimum value, this is a happy phase, you know, it's a happy phase, and its minimum value will be here somewhere. So I can find, this is the graph for the dy by dx. Okay, remember this for this expression. And I can find the coordinates of this point. This is very easy. You know, this is 6x squared minus 6x minus 12. Take the 6 common. So you will have x here minus x and minus 2. Okay, 6 will remain here. So divide this x with the somewhere with the 2. So the square of this thing, x with the 2x, sorry. So you will get 1 by 2. So the square of the 1 by 2 will be added. Square of the 1 by 2 will be subtracted. Okay. This is completing the square. So in your rough work, we divide x with the 2x, you get 1 by 2. So 1 by 2 square is added. 1 by 2 square is subtracted, completing the square. Okay. Now this will become 6 bracket, and this will be x minus 1 by 2 and its square. This is minus 1 by 4. And then you have minus 2. Okay. So you will have 6 bracket x minus 1 by 2 whole square minus, this is 4. 4 2s are 8, 8 and 1 9, 9 by 4. Okay, so you will have, just multiply it. So you will have x minus 1 by 2 whole square minus, when you multiply here, so cancel 54 divided by 4, and that will be 27 by the 2. Okay. So now this completing the square has been done. These are the coordinates. You change its sign. The coordinates of turning point are 1 by 2, comma minus 27 by 2. So the minimum value of gradient, I think, is minus 27 by 2. Let me check. And this happens at the x equals to, yeah, 13.5. Minus 13.5, yes, that's true. And this happens at 1 by 2, the value of the x. The value of the x when this minimum grade happens on this value of the x. The x is equals to 1 by 2. Now put this x value into the original equation. Where is the original equation? Here. So y is equals to, I wrote here somewhere original equation. Where is my original equation? Yeah, this one. Y is equals to 2 into 1 by 2 and its cube minus 3 into 1 by 2 and its square minus 12 into 1 by 2 and plus 7. Okay. So I put that x value into the original equation to find out the value of the y, because I need to find out the coordinates of that point. So 2 multiply bracket 1 divided by 2 bracket close raised to power 3. Okay, then we have minus 3 multiply bracket start minus 3. Okay, multiply bracket start 1 divided by 2 bracket close square, and then you have minus 12 multiply bracket start 1 divided by 2 bracket close plus 7 equals to, the answer is 0.5. 0.5 means y is equals to 1 by 2. So the point at which the gradient is minimum is this, and the minimum gradient minimum gradient is minus 27 by 2. Okay, so let me check the answer, sir. So this answer is 0, 0.5, 0.5. This is the coordinate of that point, and the minimum gradient will be minus 13.5. So our answers are right. So this is how you will do the question number 13 of the exercise 8B. So, my dear students, we have completed the exercise 8B. This was the last question of this exercise. And this is the episode 6 on this exercise. The exercise was about the stationary points. The main topic is further differentiation. Further differentiation is chapter number 8 of the course book of the Maths, Pure Maths 1. And this is A Levels Mathematics 9709. Its paper 1 is related with this. So, my dear students, the main theme of this live session is to provide the solution, step-by-step solution for the whole of the course book. I will try to provide that, and I'm working on it. And that will be very helpful for those students whose they have adopted for AS Maths and their maths is little weak. So they grasp the concept if somebody helps them in doing all the questions. Very brilliant student, they don't need to do this. So if you think that this video is helpful, and if you think that this video can be helpful, please like this video. Please share the link of this video with your class fellows, with your students, with your fellows who are feeling difficulty in preparing their pure maths paper 1. And share the link of this video on your social media accounts like Facebook, Twitter, Instagram, Twitch, TikTok, wherever it's possible. You see, when you like my video, when you subscribe my channel, when you comment on it, and that's a big support for my work. Your support is very important. So thank you very much, everyone, and have a good night, sir. God bless you all.